Hey, welcome back. So today we are going to solve Leetcode question number 34. Find first and last position of element in sorted array. We are given an array of integers, nums, sorted in non-decreasing or you can say in ascending order. Find the starting and ending position of a given target value. If target is not found in the array, return array of two values -1 and -1. Also, we must write an algorithm with logarithmic runtime complexity. So you can see the target element is 8 and 8 exists here and here. So the indices are 0, 1, 2, 3, 4 and 5. So 8 exists at index 3 and index 4. So we would be returning array of two values with indices of both the 8, 3 and 4. Now coming to the second example, the target is 6. Since 6 is not present in the given array, we would be returning -1 and -1. To the third array, the array itself is empty, so we would be returning -1 and -1 simply. So let's forget the logarithmic runtime complexity constraint for a minute and try to think of a first brute force approach which instantly comes in our mind. Let's say we have array 5 7 7 8 8 10 and the target was 8. How we would have approached? We would have simply iterated over the array. Something like we got to 5, we got to 7, we got to another 7, then we found the target. So we can have a result array where we would be uh, iterating over the array and storing the indices of the target if found and appending it to res. So if it was if indices were these, so we got to a point here and we would have appended 3. Continuing the iteration, we again got the position of 8 as at fourth index, so we would have appended fourth in the resulting array, and simply we can then return answer, which is res array. So this is a valid approach, but the thing is, the question asks us to get the solution in logarithmic runtime complexity, not linear runtime complexity. So how we can approach for logarithmic runtime complexity? Let's see. Let's go for a binary search approach. Since the array is already sorted, let's first take the same array for consideration, where this was the array and target was 8. So how we can find the first and last position of the given target element using binary search? Let's see. Uh, let's try to first get the first position of the target element 8. Target element 8. So we can define a function which would be uh, helping us get the first position. So let's say our function was first position. This was our function. So we can directly apply a binary search where we would be using the low and high pointers and running a binary search algorithm to get the target element, but the first occurrence of the target element. So let's say if we had got mid here, so since 7 is smaller than 8, we would be discarding these elements and moving the low pointer here. So low comes here and we check for the mid again. So Mid was supposed here. Now let's see if 8 is equal to target. Yes, 8 is equal to target, which is 8, and the index was, let's also mark the indices 0, 1, 2, 3, 4, and 5. So it the mid index is at 4, so we would be storing the first as 4. Since we are finding the first position and we have already got an element 8 lying at a given index, so it won't be feasible to go again towards the higher search space, so we would be contracting the higher search space towards the lower to get the first position of the given target element. So we would be like discarding these and moving the high pointer towards the low. So this would be discarded, this would be discarded, and we would be moving high here. Now we again find mid, so mid appears here. Yeah. This is the now current position, and high, low, and mid all are coinciding with each other. So we check if the element at mid, which is 8, equal to 8. Yeah, it is. So we can update the first variable with the new index of 8, which is 3. And you can see we are left with no other elements, all are discarded now. So we had found the first position as of 8 as 3. We can also now the first position is in our hand, and our next step is to get the last position. So we can define another function, let's say last position, and we can similarly run a binary search but for finding the last position. So since for the first position we were discarding the higher search space, to get the last position we would be discarding the lower search space, and similarly we would be getting last position as 4. So you can see we are defining two functions, both are running in logarithmic time complexity. Since if you would have added O log n plus O log n, we would be getting 2 log n, which is uh, nothing but equivalent to logarithmic time complexity. Big O, the big O result is a logarithmic n. So you can see that we have arrived from the linear scan to the binary search runtime complexity solution, and we can try to code this up. So let's move to our code editor. So we are in our code editor. So let's define the functions we were talking about for finding the first position, and a function for finding the last position. Also, let's assign the pointers here. And let's also store the first position, which would be nothing but the return statement from our functions find first, pause, low, high, and last, pause, find last, pause, low, high. And we can then safely be returning the first pause and last pause. Now let's complete the function find first position, passing low and high as parameters. Let's assign first pause variable, initially storing -1 as answer. So while the low pointer is less than equal to high pointer, let's get the mid index, which is low plus high by 2. Also, let's try to store the element at the mid, which is current element, nums of mid, Now let's check. If the current element was equal to target, we would be storing the index of the current element, which is mid. Now, how we can decide the search space, like where to search for the first position of the current element? So, if the current element was smaller, or if there were multiple occurrences, so the less than equal to is checking for smaller as well as the first position if there were multiple occurrences of the same element. So in this case we would be moving towards suppose we yeah we would be moving towards the lower search space. So high would be going towards the lower search space, which is high is equal to mid minus 1, else low would be moving towards the high search space, and we can then finally return the index of the uh, target element, which is the first position. So returning the first position. So let's also try to complete the last position function, passing high and low. So we should check only one thing. If the current element is equal to the target, then last position variable would be storing the index. And if the current element was greater than equal to the target, so we would be trying to search in the higher search space for the last occurrence of the element. So low would be going to mid plus 1, and in else case high would be moving towards the low, and we would be returning the last pose. So this was it, and let's try to run the code. Okay, we have a invalid syntax. Okay, yeah. Yeah, here as well. Okay, so our code is failing. Let's see why. Okay, so our condition checks are wrong. Actually, if the current element was greater than or equal to target, in that case, high would be reducing and moving towards the low. And if the current element was smaller than equal to target, in that case, low would moving toward mid plus 1. So let's check now. Yeah, and as you can see, our code got accepted. Let's submit. It's accepted, and it's pretty efficient as well. So that was it, and I hope to see you soon.